So back in 1969, Ken Thompson wrote the first cut of Unix. You might be familiar with Unix. Unix is sort of the original operating system that GNU heard, and I don't know why I mentioned GNU heard, but anyway, that Linux tried to emulate as a free um, alternative because of, I think, the licensing issues at the time. Doesn't matter, not the point. Anyway, Ken Thompson wrote this first iteration of Unix in 1 month. He wrote it on a PDP-7. Now, if you're familiar with the PDP-7, it had an 18-bit word, which is weird. We do, smaller words now. But what that meant is that it had roughly about 32 kilobytes of RAM. For the time, it was a lot. For today, it's absolutely nothing. It operated at a 1 megahertz clock speed. And now to give you some context, 1 megahertz clock speed, your operates at about 1 million times as much. From a timing point of view, you can't possibly imagine how fucking slow 1 megahertz is if you were going to try to run a modern operating system on it. It'd be basically impossible. Memory, this 32 kilobytes. I mean, if you open an empty Chrome browser tab, that's about 1,000 times more memory than the PDP-7 had. Its interface was a teletype, and if you're old enough to know what that is, good for you. But what a teletype is it's essentially a keyboard with a printer, and your interface to the computer is to type into a keyboard and see stuff print out on the printer. No screen. That's a teletype. Now, Ken wrote this in about 4,000 to 5,000 lines of assembly code for the PDP-7. C didn't exist yet. C came around when Dennis Ritchie decided to rewrite Unix in kind of like the second iteration to make it more portable. So the original cut was pure assembly code. And if you're familiar with assembly, then you know it's a vertical language, meaning, it's actually more lines per content than what we're used to today. So like if we have a for statement in like Go or whatever language we happen to write in, it is packing a lot of capability into just that one line, whereas assembler, it's just mnemonics that map to machine instructions at the end of the day by line. So that just to give you an idea of this project. Now, why do I say this? Because the internet meme of today is coding is no longer the bottleneck. Everybody likes to talk about it. It's one of those things that CEOs sort of cling to as the basis for their reasoning about why they're planning to eventually get rid of all the engineers one day. But if Ken Thompson can pull off Unix in 1 month, and this meant like the file system, the shell, the kernel itself, was coding ever really the bottleneck? And granted, we have found ourselves in this sort of endless cycle of resource consumption in the tech industry over the years. So I'm going to be, let's not blame CEOs for everything, right? Let's blame ourselves, right? So if you have a resource available to you, you can be guaranteed that you will use it, and we have. We write bloat. Software developers love to bloat the shit out of everything they do for whatever reason. A modern browser is the best example of it. It's disgusting. From a resource consumption point of view, it's absolutely disgusting. You can blame Brendan Eich, another guy who in 10 days produced JavaScript. Not a good example, but we're bad at this. We don't make economical decisions as far as how we craft code. It may be, and this is one place where I'll give the cult of Rust some credit, is that they do a hell of a lot better job of resource consumption than any other modern language, and I say modern language because obviously with C you would be equally as economic in your decisions, kind of because you have to be. Anyway, back to the point. We use the resources, we consume the resources. But was code ever the bottleneck? No. In fact, it's not code that's the bottleneck. It is all of the activities surrounding the act of coding that have always been the bottleneck in software development. And what I mean by that is just the way things become ideated, the way that initiatives get kicked off in organizations, the way that we plan, the way that we organize across silos within the organization, the way that we coordinate across teams. All of these things are plagued by bad decisions and just bad thinking. And ultimately, that culminates in software development teams not being able to deliver anywhere near as well as they could, because of those constraints. It wasn't the code. I mean, you can see it now, right? We're hearing about it. The promise of AI to sort of 10x things it hasn't materialized, and the reason for that is not because it doesn't make you more productive, because in fact it does. It's because the act of coding itself was always going to be limited and constrained by the organization around the act of coding. So one dude in his basement, like me, I'm getting shit done really fast. In an organization itself, even with these tools, things aren't moving. And the reason why is because the AI companies, who the only thing that they're selling is the productivity tool, have made the promise that this is the thing that changes everything, except that it's not, right? For me, the AI tool is a refactoring IDE, like I use Golang sometimes, on steroids. It is, yes, it's very fast to be able to produce slop, but you got to rework that slop. So some of those gains are lost. And at the end of the day, you got to ship that code, meaning you got to test it. You've got to add operability to it. It has to properly work through a CI/CD pipeline. You need to make sure that it is the right thing. This is another thing that is one of the biggest problems in software development, is like building the thing right and building the right thing, right? So building the thing right is like all of the craft that goes into building software. It has to be there. And guess what? The AI doesn't do it. The AI doesn't do it. And building the right thing, this is a matter of getting feedback from customers. And again, iterating and knowing that this is actually, I'm on the right course to satisfy customers through delight. Those are hard nuts to solve at the end of the day. And in no way does the AI help with that. So, it's a grift. Like, do you want a good example of why it's all bullshit? So the promise was that, the AI is going to replace the engineers. Okay, well, then why is it that Anthropic are hiring an army of consultants, right? Here's why. Because the CEOs are going to replace the engineers. And then at some point, they're going to hit that inflection point of, oh, fuck, we've got a lot of technical debt. What did we do? How do we navigate out of this? The engineers don't want anything to do with us anymore, and now they're asking for way too much money. What should we do about this? And lo and behold, Anthropic comes with their consulting company of forward-deployed engineers who can actually help you navigate out of the shit show that Anthropic created. It is a grift as old as time. It is. It's like the drug deal grift, right? It's like, hey, buddy, you wanna smoke some crack? Free. It's free. Take the crack. Smoke the crack. You'll love it. No charge. It's me. It's me being good to you. It's me being your friend, buddy. It's me. With you. We're buddies, right? Smoke the crack. That's the grift. That's what they've been doing to you, and we fell for it. That's how fucking stupid we are. We're dumb. That's the grift. That's where we are right now. But again, I don't want to blame, and like in my last rant, I don't want to blame the CEOs for all of this, because kind of, software engineers, we've done it to ourselves to a certain degree, right? We've always known that coding was just a very small part of our job, and we've failed pretty miserably at the rest of it, right? We could have actually put the effort into making sure that we push back on bad requirements, right? That we basically say this is not how we should be working as a cluster of teams. This is not the right way to operate software and make it visible and observable. We could have done that. We could have done that, and we didn't. We didn't. I mean, some people did, right? But on the large, we failed at these things. And we have created a situation where, we've reinforced the idea that engineering is a black box that should be this sort of deterministic function where you put information in and you get information out. And of course, it abides by the rules of garbage in, garbage out. The greater organization loves you when you're producing the right results, and then they want to kick you when you're producing the wrong results. But that's our making. We did that. We did that by not engaging with the greater organization, by not really wanting to understand how they work and how we can help them. We did that by not caring about the customer and basically saying, no, there's got to be somebody else who could talk to the customer for us. You just give us requirements and we will use our magical abilities of English to disambiguate what the hell's on the page. If we can't do that, AI can't do that, by the way. That's part of the problem. And sorry, again, let me go on a side tangent here. People keep saying that English is the new programming language. English is the worst programming language. It is ambiguous, right? If you take the same prompt and you feed it into the same LLM twice, you will come up with two different results. That is not a programming language. That is a suggestion that is subject to interpretation. Sorry. The programming language is the programming language. It is unambiguous. If you feed Go into the same version of the Go compiler twice, you come up with the same fucking result. Stop saying English is the new programming language. It is not. It just isn't. Shut up. Just shut up. Okay? Anyway, yeah, we've kind of done it to ourselves. We can navigate out of this. We're maybe a year away from being the saviors of these companies once they realize that Anthropic and OpenAI have been sort of navigating a Pareto curve, right? So the idea is like I have to imagine, if you imagine a Pareto curve, I should draw it, right? They are somewhere around like the 80% where it becomes like exponential. And they keep promising major advances, but the ability to achieve those major advances becomes almost like overly costful, such that they'll never be able to achieve it themselves, and it's unlikely that any company will accept the cost passed on to them. So they're basically toast. And how do you know that they're toast? Because they've stopped advancing. The models have stagnated, right? They advance a little bit, or they start to meta combine them and shit like that, right? And they've been investing more heavily in tooling and automation around the models. So like how to corral the slop that gets generated by these models is now their business model rather than advancing the models themselves. So put it this way, the models are done. There's no way from like a pure statistical point of view they can advance in a way where they can ever replace anybody. We are now at that point where the return on investment is just gone, and the only thing that they're going to end up being able to do is charge us more because they can't operate. So they're going to need us. They're going to need us engineers, which is why I said keep coding. Keep coding. It may be in the future that we come up with some new language that is more amenable to kind of like write once, read many, because I think that that's a better fit for using LLMs to do things, like something where you give it English and it produces something that resembles P code in some way, so you can at least read it and say, yep, that's what I meant, and then that's it. That'll be the interface. But we're kind of at that point now already with some languages anyway. Like if you've ever looked at Go code is definitely one of those languages where it's like it's ugly as hell, but it's designed for being able to read many, many times. There's no magic in Go, right? So like I think we're close to that point. For me, Go's my language. For you, it might be something else. It doesn't matter. Let's stop with that religious war shit. I think we've got a bigger war to fight. All right. So that's my rant for this week. Not as much of a rant. I'm not as angry this week as I was last week. And I want to remind you again, we also contribute to our suffering. So we can help navigate the industry out of this. Let's not blame only CEOs, although they are heavily to blame for a lot of dumb decisions. All right, see you next time.